types. We have a line and a quadratic. We'll have no solutions. We could have one solution, or we could have two solutions. Can we ever have infinitely many solutions here? No. A line and a parabola, think about that U-shaped graph. They would never be the same. They would never be on top of each other like we had with those two lines before. So that's going to be what we're getting into today. So you guys want to flip over. We're going to go over with linear and quadratic. We'll go over a couple questions together. We'll kind of go over how you can use the calculator to check your solutions or also find them graphically. And then you guys will have time at the end to do your homework. So this packet for notes is our notes for this class and our next class. So make sure you bring this with you next time too. We're just going to go over linear and quadratic today. Next time we'll go over quadratic and quadratic systems. So we're going to solve algebraically using substitution. So what do you notice about this setup with our first question? We'll get there eventually, but not right now. Think about just starting off with substitution. What do you know? Just about that idea of substituting. They both already have what by itself? They both already have y by itself. So let's think, if they both have y by itself, what can you do? Good, set them equal to each other. So we have them set equal to each other. So from here, think about this is where we were at our last unit. In our last unit, we were solving quadratics. So what strategies or what's your next step when you're thinking about solving a quadratic here? You want it all on one side. You want your quadratic always equal to what? 0, good. And when your quadratic's equal to 0, you could do a couple things to solve, right? What's kind of always your first thought when you're solving? Okay, when you are talking about GCF, you're talking about, factor. So you want to think, can you factor? What do you use if you can't factor? Yep, the quadratic formula. So we'll kind of go from here for solving. So let's think. We want it all on one side. So we're subtracting 2x and 18. So we have x squared plus 3x minus 28 equals 0. So we have it equal to 0. We want to ask ourselves, can you factor here? And can we factor? Yeah, so what are our factors? Good, x plus 7 and x minus 4. So I have it factored. It's set equal to 0. I should be able to find my solutions now. So let's think. If x plus 7 is equal to 0, what is x? What was that, Dave? Negative 7, good. And then what's our other solution? 4. So is this where I stop? Does this mean I'm done? No, we only have our x's. What do I also need to find? The y, and the process is still the same. So thinking about why that makes sense, because at these two x values, that's where this line and this parabola are intersecting. So at these x values, they'll also have the same y value. So it doesn't matter which one I plug it into? No, but what one looks a little easier, the quadratic or the linear? The linear is probably looking a little easier. So just kind of make it as easy as you can on yourself. So thinking about just plugging it in. So y would equal 2 times negative 7 plus 18. So what's your y value equal to? 4. Good. So one point I know is negative 7, 4. Remember writing that as an ordered pair. And then I'm going to do the same thing for when my x is 4. So what is our y value when x is 4? Good. So my other point is 426. So at those two places, it's where that line and that quadratic are intersecting. So let's kind of go over real quick just to show you 1 time 0 how you can use the calculator to find your intersections. So when you have your graphing calculator, so you're just going to start off by going to your y equals the top left button and entering both of those. So your y1 will be your quadratic, your y2 will be that linear, just entering both of those into y1 and y2. So just thinking in general for later problems, they both have to be in that y equals format for you to use the calculator. So take a second, enter both of those into the calculator, and your y equals. Alright, so when you have both of them entered into your y equals, from here, you're going to hit the second button, which is your, the blue button in the top left corner, and then trace. So second trace. So looking on this screen here, what do you think we're probably going to hit next? Intersect, right, option number 5. So first it's saying first curve question mark. If you have a question mark on your screen, that means it's asking you a question. You need to do something. So first curve is just saying, like, make one of them a curve. So it doesn't really matter what you're doing from here. You're just hitting enter 1, 2, 3 times till you have no more question marks. It's giving you your intersection. So where was one point of intersection? It was 426. But let's think about what's on our screen right now. Can I see that second point of intersection over here? No, so if you want to see it, you can always hit zoom, which is your middle button, top middle, and then zoom out, which is 3. After that, you have to hit enter one more time to get it to zoom out. So I already got this intersection on the right over here, which was 426. But I also have another one that's on the left over here. So I'm going to do that process again one more time. So where did we go first? Where do I go to get that intersection again? So what'd you do? Before I hit trace, what do you have to hit? Yep, second, and then trace. And then it was what option? 5, good. So second trace, option 5. If I was to hit enter, enter, enter again, it's going to give me back that point of 426. I already know that point. Do I want that point? No, I want this one over here on the left. So to get it to give me the point on the left, I'm going to move the cursor by hitting that left arrow here. So I'm around that point of intersection. So now my blinking cursor is kind of over near that. And now it's still asking those 3 questions for first curve. So I'm going to hit enter 1, 2, 3 times. And then it gave me that other intersection point of -7, 4. So was that what we got? Yeah, good. So those are good kind of checks for you. So think about -7, 4, maybe some point over here. 426 up here. Graph looking something like this. The graph doesn't need to be perfect. More so kind of getting in the habit of using the calculator to check your work with those intersection points. So let's go through setting up, and you guys we'll set up two together, then you guys will kind of finish it out on your own. So we are solving this one with substitution again. So thinking from here, is this one set up? It's good to go for substitution? Yeah, how do you know? What do you see one of the equations have? Yeah, one of the equations has a y equals. So just thinking in general, like if I was to solve, I don't know, like my first equation for x, I would still have a y and an x squared. That's not going to help me out. Think about what you want. You want all of the same variables. So I want to have all x's or all y's, but in this case, if I have an x squared and an x, I want to get it all in terms of those x's. So my first equation is already in the y equals. That's good to go. That means I can just go ahead and plug this right into that y in the second equation. So we would have 3x plus x squared minus 10x plus 17 is equal to 11. So once again, what's our next idea? What do we want to have our next goal to be?
Set to 0.
Good, set equal to 0. So I'm going to also rewrite it by having x squared minus 7x. Think about I'm subtracting 11. So I have it set equal to 0. Now what do I want to ask myself? Can you factor? So can we factor here? Yeah, what are those factors? Good, x minus 6 and x minus 1. So we've factored, set equal to 0, so now let's solve for our x values. So I know x should equal what first? 6, and x also equals 1. So from here, I'm going to leave it up to you guys to solve for y. What should you be doing to solve for y? Good, plug in the x value. So what you're going to do from here is you're going to solve for y. You're also going to use the calculator to check it. But if I'm using my calculator, my second equation, what does it have to look like first? Equal to what to plug in the calculator? Y equals, right. So why don't you guys take a second and solve your y's, check it with the calculator, and then from there, we'll check back in. Together. So when your x was 6, what was the y value that you got with it? -7. Then when your x was 1, your y value was 8. Good. So remember last unit, every time you took the square root, what did you have to write with it? Plus or minus. So how many times did I say that like every class? Like 25 maybe? So what did a lot of us still forget to do on our test? The plus or minus. So kind of the same idea with this unit. One thing we always want to make sure we're doing is writing our answers as ordered pairs, because there's a point where they're intersecting. So you should be writing it as a point, because you don't want to just write x equals 6, x equals 1, y equals -7, y equals 8. That's not showing that that 1's going with the 8 or that the 6 is with -7. So make sure you're writing each of those as points. Having any questions so far? Are we feeling okay? All right, so let's look at, you guys are going to actually try 3 and 4 on your own, both with using substitution. So kind of take it by doing substitution with whatever method you want, except for with number 3, I would not solve the second one for y and set them equal to 0. That's just going to kind of make things probably the most difficult for you. So why don't you guys try 3 and 4 on your own for like 5 to 10 minutes, then we'll check back in. So after you solve them, you can use that graphing calculator to kind of check your answers to make sure you're doing it right too. All right, so let's focus back in. So you guys, with this one, it was a little bit more difficult with our substitution. So kind of thinking what you could have done first was just simplify this out. So remember, when you have that x minus 3 squared, you want to write it out side by side, multiply back through, or that's your square, double square as well. So that would be x squared minus 6x plus 9 plus 4. So don't forget your order of operations. Go back to your basics always. Remember, exponents come before multiplying. So squaring that x minus 3 should happen first. Then you can multiply everything by a half, which would give you 1/2 x squared minus 3x plus 9 over 2. And then you can add that 4 with your 9 over 2. So just kind of don't forget about those basics. So this is what our y will be equal to. So y will be equal to 1 over 2 x squared minus 3x. So 9 over 2 plus 4, just your fractions. So think about 4, to have a, adding with 9 over 2, you have to have a what? Common denominator. So 4, I could write it as 8 over 2. So what's 9 over 2 plus 8 over 2 become? So think 9 plus 8 would be 17 all over 2. So we would have x plus 2 times our y will become 1/2 x squared minus 3x plus 17 over 2 would equal 13. So now it's not that big of a deal that we have these fractions because I'm multiplying everything by 2. So x plus x squared minus 6x plus 17 equals 13. So this is back to where we've been before. What do we want it to be equal to? 0. Good. So think about our x squared minus 5x. And then this would be plus 4 equals 0. So then you want to ask yourself, can you do what? Factor. Can we factor here? Yes, what are factors? X minus 1 and x minus 4. So I know x should equal what? 1, and x should also equal 4. Good, so when we got x equaling 1, what was the y value that went with that? Not 5, but 6. And when our x value was 4, what was the y value that went with that? 4.5, or as a fraction, 9 over 2.
Do you have to use fractions?
So you can use decimals if the decimal ends.
Yeah.
Like, would I ever want to keep like 2 over 3, right? Would be like 0.66 or so repeating. I'm not going to just write 0.67 because that's not equivalent to 2 over 3.
Okay.
So you can write decimals if they end, but if not, then just use fractions. And then with question 4, how could we set up question 4? What do you notice about question 4?
Equal to each other?
Yep, you could write them both equal to each other. So you just have x squared plus 4x minus 2 is equal to 6x minus 3. So when we have our, now we want it equal to what?
0.
0, good. So we should have x squared minus 2x plus 1 is equal to 0. And then we want to ask, can we do what? Factor. Can we factor here?
Yes.
Yep, so we would have x minus 1 and another x minus 1, which means our x is equal to what?
1.
1. So what do you kind of already notice here? You're going to have how many solutions?
1.
Just 1. What was the y value? 3. So your one solution should have been 1, 3. All right, so